Okay. So here we go. We're going to be talking about CBA 9 review, which is mostly just on data and some personal finance stuff. Okay. So let's talk about a couple different things here. Here we're talking about box and whisker plots, or just box plots, however you learned it. They're the same thing. Okay. So it says it shows distribution of test scores for 2 students for a semester. What conclusion can you make about the data? So when we have box plots, we're supposed to have really 5 points of data. When we add our interquartile range, we actually have 6 points of data. So we have two names here. I have Jim and I have Suresh. All right, so we have Jim and Suresh, and they need some key pieces of information. Okay, they need to find a minimum, quartile 1, a median, quartile 3, a maximum, and of course our interquartile range, which is just Q3 minus Q1. Okay, for Suresh, we'll do the same thing. He needs a minimum, he needs a quartile 1, he needs a median, he needs a quartile 3, he needs a maximum, and then he needs an interquartile range. Cool. So, easy ways to identify these are with the points that we have in the actual box plots, okay? So this would be our minimum here. Okay, it's the same piece of information for both people. Here we have our quartile 1, quartile 1. It doesn't matter if it's a top or bottom corner, so long as we understand that that particular data point represents your very specific quartiles. There's our median. There's our median. Quartile 3, quartile 3, our maximum, and then of course our maximum. Okay. So if we look at our number line, we can see that they're skip counting by 2s. So I'm going to go ahead and just fill that out too. 72, 74, 76, and so forth. Okay. So that's what I'm doing here. 96, 98. Perfect. Okay. And that's going to help me out when I'm filling out the rest of this information. Okay. So here we go. Our minimum for Jim is going to be 72. Our quartile 1 is 76. Our median is going to be 80. Quartile 3 looks like 86. Our maximum is going to be 90. And our interquartile range is Q3 minus Q1, so 86 minus 76. That means for Jim, his interquartile range is 10. And we'll do the same thing for Suresh. Suresh's minimum is between 86 and 88, so we're going to say it's 87. Quartile 1 is 92. Median is 94. Quartile 3 is 96. Maximum is 100. And our interquartile range is 96 minus 92, which in this particular case is 4. So now all we're going to do is look at the answer choices and see which ones make the most sense. So for A, it says the range of Jim scores is 10. Now, notice how I specifically said interquartile range. Interquartile range is just between your quartiles, not your maximum and your minimum. And that's how we find our range, our largest number minus our smallest number. So in this case, for Jim, the largest number was 90, smallest number was 72. The difference there is 18. So A is incorrect. For the interquartile range of Suresh's test scores, they're saying here is 13, but when we did it, we had 4. So B is also not correct. The median of Jim's scores is 80. So far, that's the only one that makes sense. And then D says the half of Suresh's test scores is between 92 and 96. Well, that's not true if we're talking about a range of 87 to 100. A range of 87 to 100, half of that is not going to be between 92 and 96. So again, that's not right. That's correct. And we can connect that median line right to the 80, and that's how we know it's true. All right, moving on. Number 2. Okay, there's two key pieces of information here. That's super important. So, key piece number 1 is the smaller your box, or smaller your interquartile range, you get more consistent scores. Okay, consistent scores. Okay, second thing that's really important here is going to be that if you have a higher median, then you're going to have higher scores. All right. So here we don't have to do the same thing we did for earlier, but we just have to look at our answer choices. Okay. It says overall Samir had better scores than Holly. Well, again, we just wrote down some pretty key information here that if you have a higher median, then you have higher scores. Here's Samir's median. Here's Holly's median. So overall, Samir did not have better scores than Holly. So immediately, that's not true. Look at B. It says overall, Samir had better scores than Holly. Again, immediate red flag. We know that's not true. It says, and Holly was more consistent with her scores. But Holly's box, the data for her box is spread in a way that's longer than the box of data that's spread here, right? We just wrote that if you have a smaller box or a smaller interquartile range, then you have more consistent scores. So that's doubly wrong, basically. C says overall Holly had better scores than Samir. Okay, so that she had a higher median, so we know that's true. And Samir was more consistent with his scores. Well, he has a smaller box, so we know that's true. C is going to be the correct answer there. All right. When we look at number 3, it says a stem and leaf plot shows the number of toys collected by various schools for a children's center. How many schools collected more than 47 toys? So biggest thing here is how many schools collected. Big thing is more than 47 toys. Okay, fortunately for us, that's all going to be within this range of data here, okay? Now, the key is very important because they're telling us that if we have this number separated by this vertical line and this number right next to it, then it really equals 30. So the same thing here. This is 50, 51, 54, 59, 50, or 57, 58. All I'm going to do is write them out. They're already in numerical, or not numerical, of course they're in numerical order. They're already in order from least to greatest. I'm just writing it out, and you don't have to, but this makes it easy for me. It depends on what you want to do. You can say 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. Anyway, we're looking for how many schools that collected more than 47 toys. Answer choice here is B. 5 of those schools collected more than 47 toys. All right. Next page. Here we go. All right, for this page, here we go. It says that a traffic engineer is collecting counts of how many cars are on one street during a specific time each day. Where the results are shown in the histogram, which statement is best supported by the information in the histogram? So, again, I like to fill out these the missing information if I can. So here on our y-axis, you see that we're missing some just a few numbers. We're skip counting by 1, so I'm gonna say 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12, 13. Okay, so now I have some more information that helps me when I'm finding out what my histogram bars represent. So this number is 3, this number is 7, this number is 13, this number is 10, and this number is 5. Perfect. Now, what I'm going to have to do when I have this is this represents the number of cars, okay? So if I need to represent the number of cars, and I need a total amount of cars that happened to pass by this particular street at this particular times, okay? So we're going to add all this up. That's going to be 10, that's going to be 23, that's going to be 33, that's going to be 38. So we have a total of 38. And really it's total days because that's what's being accounted for. Okay? So let's look at our answer choices here. I want to put that up here. A, the traffic engineer observed only 3 cars for the first 14 days. Here's 1, 2, 3 days. And in those 3 days, they witnessed 0 to 14 cars. So that is wrong. B says more than half of the drivers do not prefer driving on the weekends. Again, they're talking about whole days. They're not talking about weekdays or weekends. So that one makes no sense. There are more cars during the morning time than the evening time. Again, they're talking about whole days. They're not talking about time of the day. So that's going to be wrong as well. By process of elimination, this is going to be our answer. But also, the engineer collected data for 38 days. It's also the only answer that actually, speaks of any truth in this particular case. All right, number 5. Here we go. Okay, for number 5, it says the data set and box plot show the times and minutes for 16 restaurant orders. Describe the shape of the data distribution. So we're just talking about what the data distribution looks like, okay? Now, if it's skewed to the right, then we know a lot of the data would be over here, right? It would be leaning over here because we would be moving down to the right. If it was skewed to the left, all the data would be over here, and we will be scooting down to the left. Approximately symmetric is definitely going to be our answer, okay? If I were to split this data set in half, then basically these two sides are identical, okay? Here it says approximately, which is, it doesn't have to be exact, okay? So long as it's very close to, and it looks a lot like, then we can say it's symmetrical, okay? So in this case, our answer choice is B. D, it says there's not enough information. That's just not true. I can find my minimum, maximum, median, quartiles. I can find my range, my interquartile range. I can do all that stuff, okay? I can even find my mean. I can do all that stuff here. So for them to say there's not enough information, it's just not true. All right. Next one. All right, number 6. It says 2 ranchers were surveyed to find the number of cows, pigs, and chickens on their ranches, and the results of the surveys are shown in the table below. Make a double bar graph to compare the data in the table. So a big thing here was paying attention to the keys, okay? So there's several keys here. This table is going to be our key because it's telling us Double X Ranch has this many cows, this many pigs, and this many chickens. Silver Spurs Ranch has this many cows, this many pigs, this many chickens. But then when we look at the other, there's 4 of them here. So just so we have like a little piece of information, okay? When we look at these, they all kind of, their keys in particular change, okay? Here, the gray represents Silver Spurs and the black represents Double X. But then if we look at the answer choice next to it, the gray represents Double X and the black represents Silver Spurs. So we really do have to be careful with that, okay? So let's see what we can do for the first couple that we see up here. So we have 10 cows for Double X Ranch. Here's Double X Ranch. I have to make sure that it says 10 cows. Well, that's way too many cows, so immediately A is gone. Let's go to cows. Double X has to have 10 cows. Okay, Double X has, again, more than 10 cows. I can't choose C. So we know we're done with those. Again, 10 cows. Double X, right? Double X is this color here. It should say 10 cows, but it does not. So B is not our answer. D is our answer. Double X, 10 cows. Silver Spurs, 15 cows. So that one actually works. All right, next one. Yeah, this way. Okay. This one looks more complicated than it is, and thankfully it's not. So we're going to do a couple things here. We're going to build our own stem and leaf plot. So let's go ahead and just do that very quickly. We can write stem, and we can write leaf or leaves. It depends on what you want to write. That's okay. Okay, so all I'm gonna do here is I'm starting with my my tens. Okay, that's gonna be the smallest types of numbers I'm gonna see here. So I'm gonna circle all of my tens and then document them. Okay, and what I mean by that is like my 16s, my 12s, my 13s. Okay, so let's do that. We're going to do 16, 17, 12, 13, 15, 13, 16, 12, 11, 13, and am I missing any? I think that's it. So now all I'm going to do is create my own stem and leaf. I know I have a 1, that's going to be my stem. So now I'm finding my smallest numbers in this regard and ordering them from least to greatest. So I think the smallest number I have is 11. So I'll write that and cross it out. Next number was 12, and that appears twice. So I have that. I'll cross it out. Then I have 13. That appears 3 times. And I'll cross them out. And then I see a 16. So I'll add that as well and cross it out. I see it twice. Okay, so I have to represent it twice. Ooh, actually, you know what? Here we go. There was a 15 first. So that's okay. We'll change that first 6 into a 5. 16. 16. So, you got to just make sure you're scanning carefully because even I just now made a mistake. And then there's a 17. So I should have 1, 7. Now, all you're going to do is look at your answer choices and figure out which one it is. Now, looking at C and D, just immediately, these are wrong. That's never how a stem and leaf plot, is going to look. So when we look at the other answer choices we have, it's really between A and B. And if I look here, I know that I had 12 twice and 13 3 times. Here, 12 and 13 only show up once. So unfortunately, that's not going to be our answer. Our only answer choice in this case is B, because again, we built what's already there, right? And that matches up exactly. All right, let's go to this next one. Okay, cool. I like this one too, because here we get to do a couple of things. We get to build our own little dot plot, okay? And I'm making my number line with the exact same values I have for the other number lines, right? So just 1 through 6, that's what we're showing, right? Cool, awesome. Now, all I'm going to do at this point is count the amount of numbers I have in this data set here, number of hours, and plot them, okay? So I see 1. I'm going to start with 1. I see 1, 2, 3, 4, 5. So 1 shows up 5 times. So I'm going to plot that 1, 2, 3, 4, 5 times. Let's look at 2. 1, 2, 3, 4, 5. So 2 shows up 5 times as well. 1, 2, 3, 4, 5. 3 shows up 1, 2, 3 times. 1, 2, 3. And then 4 shows up once. Boom. Now the only dot plot that looks literally like the one we just constructed is going to be A. Okay? Now, when we look at these data, this data set, right? Sometimes I like to ask extra questions like, hey, how would you describe this data set? And so what I've been showing you guys is to turn this into a type of slide or roller coaster, right? So here we go. This person's going down this roller coaster. They're having a lot of fun, but what direction are they moving in? To the right. So if I had to describe this data set, I would say it is skewed right. Okay? Awesome. So, add a little picture, have a little fun. Okay, let's move on to number 9. Okay, so we're going to have to do a couple things here. The number of calls responded to by a paramedic team over an 8-day period are given. Use the data to make a box and whisker plot. So, okay. When we see box and whisker plots, okay, a couple things we need to do. First, we need to, first, what we really need to do is order our numbers from least to greatest. So let's go ahead and do that. So we should have 6 twice. We have an 8. We have a 10. 12. 14 shows up twice. And then 15. All right, perfect. Cool. So we have that. Now, when we see these, we need our 5 points of data. If we add the interquartile range, then it's 6 points of data. So we need a minimum, quartile 1, median, quartile 3, and maximum, and then we need our interquartile range. Okay, now, how are we going to find all this? Minimum's easy. It's the smallest number we have in this data set, which will be 6. Maximum is going to be easy. It's our largest number in this data set, which is 15. Now, how do we find our median? Our median is going to be the number that's in the middle. So, if we look at the numbers that are in the middle, or number that's in the middle, wait, hold on. We see that we have 2 numbers in the middle. In the event that you have 2 numbers in the middle, you add them up and divide by 2. So this is going to give us 22 divided by 2, which means our median is 11. Cool. Now, I need to rewrite my list of numbers with the median included. So let's go ahead and do that. 6, 6, 8, 10, 11. I'm going to circle that so I know it's my median. 12, 14, 14, 15. Now, how do I find my quartiles? To find your quartile 1, you have to find the median of the first half of the data. This is that first half of the data. And the median, again, is going to be these 2 numbers here. And when I have that happen, I have to add them up and divide by 2. So that's going to be 14 divided by 2, which will give me 7. So I know that my quartile 1 is 7. These 2 numbers, 28. 28 divided by 2 is going to give me 14. So I know my quartile 3 is 14. Now, if I wanted to find my interquartile range, again, Q3 minus Q1, and that's going to give me an interquartile range of 7. Now, when we look at our answer choices, D should kind of stand out the most because immediately the median here is saying 10, but our median here is saying 11. That means D is wrong. Let's look at A. Minimum 6, quartile 1, 7, median 11, quartile 3, 14, maximum 15. That one looks good to me, so that's probably going to be my answer, but let's double check. Minimum, quartile 1, median. Quartile 3 is where they're messing up here. Quartile 3 is not 13, so B is wrong. Here, they're saying quartile 1 is 8. That is not true. So C is wrong. Our only answer choice here is A, and that is why. All right, let's keep going. Okay. So let's talk about this one here. The box and whisker plots show the lifespans in days of 2 different brands of light bulbs. Describe how the data distribution are alike and how they are different. Okay. So we have some things that are alike and we have some things that are different. Give me just one moment. Sorry. Okay, so let's look at Globrite and Luminate. Again, so we should be able to see that the data is definitely skewed. Okay, because if it were more symmetrical, the data would be in the middle, and it would, one half would look exactly like the other half, or very close to, at least approximately like the other half. So we know that it's gonna be skewed. So now let's talk about in which way. All right. So that seems right. Both data seem to be skewed, right skewed. So again, if I'm kind of making a little slide going down this way, they're definitely moving to the left. So when they say both data sets are right skewed, that's just going to be wrong. Okay, they're going to be left skewed. So let's keep going. They seem to be symmetrical. No. Both data sets appear to be symmetrically distributed. No. Again, that's not true. So both data sets appear to be right skewed. That is true. And here we go. It says the center of Globrite data is greater than the center of the Luminate data. Well, Globrite's median is greater than Luminate's median, so that's fine. And it says the spread of Globrite is greater than the spread of Luminate. So let's see. Globrite would be 190 to 110. That's 80. That would be 170 to 100. That's 70. So yeah. D is going to be 100% correct. So just be careful with what you're reading there. That's all. For number 11. All right, let me scoot this up a bit. Sorry. Okay, number 11. This is a good one, okay? So we can make this kind of pretty short and sweet and simple. We're going to make a dot plot, all right? And we're just going to use ranges, okay? So we're going to say the first range is 0 to 9. Second range is 10 to 19. Third range is 20 to 29. If I can write my numbers correctly. Sorry about that. And the last range is 30 to 39. Okay, so here's what I'm going to do. Here, what you want to do is you want to count the amount of times, right, the frequency in which these particular numbers within these particular ranges show up. So I'm going to find what you should be doing really is putting this in order from least to greatest, but you don't necessarily have to. So mentally just organize them from least to greatest. I have 0.1 data point. 0.2, that goes between 0 and 9. And I'm basically just doing that with all the data points that are happening between 0 and 9. So that's what I'm doing here. 1.0 is between 0 and 9. 1.1, 1.3. What else? I have 5.2. That's another one between 0 and 9. 5.9 is another one between 0 and 9. And 8.3, that's another one between 0 and 9. So basically, I'm just looking at the values, right? How often did this particular range take place? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The only answer choice that matches that frequency is going to be this one here. And so again, if we're looking at finishing it, there's 2 of them in this particular range. There's only 1 in this range and 1 in this range, okay? So again, if I'm talking about how to describe that, this will be considered to be skewed right. All right, so okay, this one's not bad. group of people were asked to name the way they watch basically television shows, okay? 8 people watched it live, 9 watched recorded, 3 watched it on demand, and 5 were doing online streaming. Cool. So when we talk about a percentage bar, we have to talk about 100%. But what does 100% mean as a number here? 100% is going to represent the amount of people that actually took this survey. So when we add up the amount of people that took this survey, we should end up with 25 total people. Okay? Cool. Awesome. Let's find out how much of these people, represented by this white bar here, watched live TV. So that's going to be 8 of the 25. So, okay, we do cowboy hat and horse, or we do the Tebow, right? Top in, bottom out. 8 goes on the inside. 25 goes on the outside. Okay, here we go. 25 can't fit inside of 8, so I do a 0.0. That fits in 3 times. That's going to be 75. Difference here is 5. Add a 0, bring it down. 25 fits into 5 twice. In order to turn that into a percentage, we swing this decimal over twice. We have 32%. So 32% of people watch live TV. And if we look at our answer choices, A can work. B is exactly at 30, that can't work. C is at 25, that can't work. But D is at 32, so we have to keep going. Our next one is going to be people who watched recorded TV. Okay, 9 people represented by the lightly shaded gray box. So we'll do the same thing. This is what, 9 out of the 25. So again, top in, bottom out. Scoot it over just a bit. We have 9, 25. All right, here we go. 0.0, that's 3, that's 75. Difference here is 15. Add a 0, bring it down. That's going to be a 6. Turn it into a decimal. There we go. So 36% of people watch recorded TV. Now, if you look here, this looks like 32 to maybe 45, which would only be about 13%. So that's going to be incorrect. Whereas here, from 32 all the way to about what looks like maybe 68 makes a lot more sense as something that represents 36%. So that's how we find that answer here. All right, this one's pretty simple as well. Again, it's not symmetrical. If we cut our data in half, it does not look the same on both sides. So we can get rid of this one immediately. Again, we're picturing that roller coaster, okay? That person going down and having fun. What direction are they moving in? To the left, which means by default they can't be moving in the right. Our mode represents our most frequent number. Here's 0. Our most frequent number is not going to be 0. So I'm going to fill this out real quick before I forget. 7, 8, we'll say 9. So by default, okay, we know that we're going to have a couple other different answers, okay? In order to find the median, yes, you have to write out all of these numbers in order from least to greatest. There's going to be a lot of numbers, but it's important because our median should be 6. So let's write out all these numbers very quickly. That's 0, 1, 2, 3 twice, 4 twice, 5 3 times, 6 and 7 4 times, and 8 shows up 5 times. Now, when you work your way all the way to the middle, which one is it? I think it's definitely going to be 6. Which one? So, Okay, so 6 is definitely our median. Okay, the mean. Okay, for the mean, you would have to add all of this up and then divide it by the amount of numbers that we have. I believe when you add all this up, you're supposed to get 121, and there are 23 data points. So that should fit in about 5 times. That's going to give you 115. Difference here is 6. Decimal 0. Bring it down. That fits in twice. That's going to give us 46, but it really doesn't matter at this point to divide any further. Here we go. The mean is approximately 5.2, or 4 rather. 5.2 is approximately 5.4. Therefore, B, D, and E are going to be our correct answers here. All right. Okay, here we go. Mean, median, and range. Okay, range is easy. It's our largest number minus our smallest number. So our largest number here is 63. Smallest number is 36. When we solve this, oh boy, sorry, we should get 7 and 2. So our range, we'll just write it here. Range is 27. Okay, let's find our mean and median. In order to find our mean, we do have to write these numbers out from least to greatest. So let's go ahead and do that. Interesting. Sorry, I was looking at something. So okay, 36, 39, 39, 40, 52, 54, 3 times, 61, and 63. All right. So, when we find our median here, we see that it's actually 52 plus 54, which is going to give us 106. Now remember, 106 divided by 2, that's going to give us 53. So our median in this case is 53. Now, when we find our mean, okay, we have to add all of these numbers up and divide by the amount of numbers that we have, okay? So 36 plus 39 plus 39 plus 40 plus 52 plus 54 plus 54 plus 54 plus 61 plus 63 is 492. Is that right? Yeah. All right, so when we add all this up, we should end up with 492. We divide by the amount of numbers. Oh no, we add this number as well. Okay, my fault. I apologize for that. JK. This should be 545, and we divide by the amount of numbers we have, which with our median is 11. There we go. Sorry about that. What do we get? 4. It's going to give us 44. Difference here is 10. Bring that down. It's 5. 9. 99. Difference here is 6. Decimal 0. Bring it down. 5. And that's where we're going to leave it. We're going to say our mean here is 49.5. All right, we're almost done with this, y'all. Let's keep on keeping on. All right. Here we go. Range, median, range, median, mean, range, mean, and median. Okay, range, again, is our largest number minus our smallest number. So we have 369 minus 181. Here we go. That's going to give us 188. So our range is 188. Now, in order to find our mean, we have to add everything up. What was it? It was like 1,800 something. 1 second. Just got a text message. Sorry about that. 181. Yeah, okay, sorry. So when we add all this up, we end up getting 1,824. And we're going to divide by the amount of numbers we have, which here is 6. So here we go. 6 fits into 18 perfectly 3 times. Bring down the 2. 6 does not go into 2, or it goes into 2 0 times. Bring down the 4. 6 gets multiplied into 24 4 times. So here our mean is going to be 304. Our median, we have to rewrite these numbers in order from least to greatest and then find the median, okay? So we're going to leave 181 where it's at, 244, 306, 362, 362, and then 369, okay? We see here that we have 2 numbers in the middle. So 2 plus 6 is 8, 6 plus nothing is 6, and then 3 plus 3 is 6. So we have 668, divide that by 2. Half of 8 is 4, and half of 66 is 33. So our median is 334. All right. We are getting there. Okay. Here we go. Number 16, find a set of 5 items that has a range. So, okay, I need 5 blank spots here. They're telling me that I have a median of 14. So that's where I'm going to put that, 14. A mode of 11. Remember, mode is when the number shows up the most frequently. So if I know 11 is going to show up the most, and I know I'm putting my numbers in order from least to greatest, then I know 11 should go there. Now, it says I have a range of 9. So usually I find my range by getting my largest number and subtracting my smallest number, but in this case I don't have my largest number. So I'm just going to get my smallest number and my range and add them. So 11 plus 9 is 20. Now, here's where the other piece of information that's kind of pretty important comes into play. It says we have a mean of 15. So if we have a mean of 15, then usually what we would do is we would add up all these numbers and divide by the amount of numbers we have. But if they're telling us our mean, then we're going to take that mean and multiply by the amount of numbers we're supposed to have. So 15 times 5 is going to give me 75. That's super important because that's essentially what I'm going to have this set equal to. Now, how do I represent an unknown? Well, we just use a variable. Now here we go. In this particular case, we are adding everything up and then solving for x. So we add everything up. We should be able to see that we have 11 plus 11, which is 22. 22 plus 14 is 36. 36 plus 20 is 56. So now we have x plus 56 equals 75. And then we just solve for x. We subtract 56 from both sides. 6, 5, 9. So in this case, x is equal to 19. So what would our missing number here be? 19. And that's how you find it. Okay? So Let's look at this next one. Here we go. Dan has a list of scores of all of his math tests and quizzes during the school year. What is the mean, median, and mode of the data sets? Okay. Order it from least to greatest. Should have 42. What's my next one? 75? 75 shows up. No, 74 shows up before that 75. Sorry about that. So 75 twice. Then we see 78. We see 79. We see 82. 85. 87. And then 91. All right, cool. So let's find our median here. If we look at these numbers, we should be able to see our median is going to actually be 78 and 79. Okay, so if we add those together, what do you call it? We get 157. 157 divided by 2 is going to give me 78.5. Okay, so that's our median. Median. Now what do they want? They want a mean. They want a median. And they want a mode. All right, so median, we just found it. That one wasn't too bad, 78.5. Our mode is the number that shows up the most, which in this case is going to be 75, just because it shows up twice. Now let's figure out what our mean is. All right, cool. So when we add everything up, our mean, when we add everything up, it ends up being 768. When we solve for our mean here, we have 10 numbers. So here we go. 776. Drop that. 8, 6, 60. 8.0. 8, so we end up with 76.8. Okay. All right. Well, let's keep going. Okay, for this one, okay, we're trying to figure out what percent of events customers came in between 12 and 4. Okay, this bar is 40, this one is 80, this one is 60, this one is 70, and this one is 25. Okay, so in order to get a percentage, we need to know what 100% of something is. Okay, in order to find out that number, we have to add everything up. When we add everything up, we should end up with 275. Okay, now they want to know what percent of Yvette's customers came in between 12 and 4. Well, 12 and 2 was 80. 2 and 4 was 60. Add these up. We get 140. So now we need to convert these two numbers, or these two numbers. We need to convert this fraction, rather, into a percentage. So let's go ahead and do it. All right, again, top and bottom out. 140 goes on the inside. 275 goes on the out. Okay. 275 fits inside of okay, sorry, my bad. 0.0. Sorry, that way it's going to make sense. 275 fits inside of 1,400 4 times. Okay. And that's going to give us 1,100 and then we subtract. Okay, we get 300, fits in once. That's 275. We get a difference of like 25. And so it's going to kind of keep going, okay? But we're looking for a percentage here. So let's turn this into a percent. So what percent of Yvette's case customers are coming in? It's about 41% of her customers are coming in between those particular hours, okay? So that one's not super hard. You just got to know what to do there. Okay, this one's actually even easier. They want to know basically an age range, right? So who's coming in between these particular ages? They're saying between the ages of 25 and 40. And you can include the ages of 25 and 40. So I'm going to go ahead and box these numbers in. Okay, so these are 5 different people with these particular ages out of the total amount of people, which is 17. And then all you do is divide. Top in, bottom out. 5 goes on the inside, 17 on the outside. 0.0, that's going to be 234. And then that fits in 9 times. It's not exact, but it fits in 9 times. It's actually 153. So we can say that 29% of this person's customers are between the ages of 25 and 40. Okay, here we go. Last one. We did it. Okay. Which time interval represents, again, about 33%? So here we have 45. Here we have 90. Here we have 50. This should be 70. Yeah, 70. And then here we have 20. When we add all of it up, we end up getting 270. Now, the biggest thing or the biggest trick I can think of here that makes this one very easy is kind of just looking at the front numbers. Okay, let me explain. So out of 270, if I get rid of my 0, I'm only focused on my 27. Okay, so I'm only focused on my front numbers right now. 2 doesn't fit into 27 necessarily evenly. 7 doesn't either. 5 doesn't either. 9 does, so that's going to stand out to me. And 4 doesn't either, okay? So I'm going to choose 9 here. Or 90 rather. So now I should be able to simplify by getting rid of those zeros. And again, 9 goes into itself once. And it goes into 27 3 times. 1/3 is equal to 33%. The time interval is going to be 12 through 2. All right. That's all I got for you guys, all right? Hopefully it was helpful.